we have covered independent sample t-test. Now, in today's lecture, we will cover, one-way ANOVA analysis. One-way ANOVA analysis. One-way ANOVA analysis. Let's discuss the theory of the one-way ANOVA first. Later, I will also guide you how to run the analysis on the SPSS. Okay. So ANOVA, we stand for analysis of variance, variability. I told you about the variance in the last few lectures. It's a statistical test used to analyze the difference between the means of more than two groups. T-test only for the two groups. Understand? This one more than two groups. Try to understand the difference between the t-test and one-way ANOVA analysis. This is also comparing the means, but more than two means. Got it? One-way ANOVA uses one independent variable, while our two-way ANOVA uses two independent. But our main topic of discussion is one-way ANOVA, not the two-way ANOVA. Maybe later some other time we'll teach you about a two-way ANOVA. Okay. So one-way ANOVA example, as a crop researcher, you want to test the effect of three different fertilizer mixture on the crop yield. Mean one IV and one DV. But IV should have more than two groups. And those groups effect can check on the DV. See, in this respect, different fertilizer mixture is the IV and the crop yield increasing or decreasing. This is the DV. You can use a one-way ANOVA to find out if there is a difference in the crop yield between the three groups. Three groups mean fertilizer mixture, group 1, group 2, group 3. Okay, later I will guide you more in detail when we will go to calculate on the SPSS, when you will have a more idea about it. Anyway, so these slides. When to use a one-way ANOVA? When? Okay, the theory now is when. Use one-way ANOVA when you have collected data about one categorical independent variable and the one quantitative dependent variable, quantitative ratio or interval scale. The three independent variables should have at least three levels. Okay, the independent variable should have at least three levels. Different groups or three categories. Suppose category 1 or maybe three levels mean higher, middle or lower level. Number 2, ANOVA tells you if the dependent variable changes according to the level of independent variables. For example, here, please concentrate on this sentence. Not your independent variable is type of fertilizer. Suppose our independent, for our study, we have a fertilizer as an independent variable. Okay, independent. So variable is type of fertilizer, and you treat crop yield. This is our DV. Okay, with mixture of 1, 2, and 3. To find out there is a difference in the crop yield, first, how influencing the crop yield. The second group, how impacting the crop yield. And the first group, how influencing the crop yield. Is it increasing or decreasing? There is any impact. But these all three groups related with or categories of, or might be we can say the level of one independent variables. Understand? So which is our IV? Type of fertilizers. Got it? Might be we have a different types of fertilizer. Nitrogen. I'm not a chemist, by the way. Might be there are many types of the fertilizer as well. Anyway, see here how we can propose the hypothesis if we going to check the relationship between the type of fertilizer and the crop yield per acre. See, the null hypothesis of ANOVA is that there is a no difference among the group means. Group means mean this one, 1, 2, and 3. Or alternative hypothesis is that at least one group differs significantly from the hour of mean of the dependent variable. Anyway, don't get confused about this one. I mean, your hypothesis should be there is a difference between the type of fertilizer and the crop yield, or there is no difference. Suppose here I'm going to improve. See, now H1 See the null hypothesis. See here. There is no difference among type of fertilizer and crop yield per acre. Okay. So what will be the alternative hypothesis? Please suggest me group number 8. This is my null hypothesis. There is no difference among type of fertilizer and the crop yield per acre. Yield, the wrong spelling. Y-E-T. Okay. So please. Nehoma. I don't know how to say.
Sir, sir, can you hear me?
Yeah, I can hear you as always. Here H1
there is at least one group differs significant from the overall mean of dependent variable.
Can you inbox?
Can.
Yeah. Kim Tik. How about this one? Charji Ling. She looking so serious. Might be she has more knowledge than us.
Doctor?
Yeah. You're sleeping.
No, I'm not sleeping.
Okay. I'm kidding. Don't take serious, lah. I'm kidding. I know. Yeah. You want to give me answer? Or you are waiting for Kim? You are waiting for the Kim reply.
Doctor, the answer will be same as the statement, is it?
Yeah, listen. See, when we have an alternative hypothesis, sorry, a null hypothesis, our alternative hypothesis should be, opposite of null hypothesis, right? Very simple. Okay, so null hypothesis, there is no difference among the type of the fertilizer and the crop yield per acre. So what should be the alternative hypothesis? There is a difference among the type of fertilizer and the crop yield per acre, right? Very simple, my dear students. Just give a little bit considerations. I'm not asking you to, to propose a Newton law. Yeah, there is a difference between, type of fertilizer and crop yield per acre. Done? My dear student. Okay. This is for your information only, note. If you have only 2 groups, then you can use only t-test. This is more than the 2 groups. So we have to use, we are comparing the means. We have to use the one-way ANOVA. Let's calculate on the SPSS now. See here, how does ANOVA test work? ANOVA determines whether the groups created by the level of independent variable are statically different by calculating whether the means of the treatment level are different from the overall mean of the dependent variables. Yeah, we are comparing the independent mean with the dependent mean. Okay, might be this mean is okay. IV category is changing or impacting the DV or not. Yes or no, we have to give the answer. If any of the group means is significantly different from the overall mean, then the null hypothesis is rejected. Yeah, if we cannot find the difference, then null hypothesis will be accepted. If we find a difference between IV and the DV, then we will go to accept a alternative hypothesis, right? Okay, maybe don't get confused. Now, let's go for the practice. Let's go for the practice. Here, assumption of ANOVA. You must know about the assumption of ANOVA before proceeding on SPSS. See, assumption of ANOVA tests are the same as the general assumption of any parametric test. Yeah, in last lecture, we covered about the parametric test as well. What requirement we need for the parametric, we covered in the last lectures. See here, independent of observation, the data were collected using statistical valid method. There are no hidden relationship among observation. If your data fail to meet the assumption because you have a confounding variable that you need to control for statically, or maybe use an ANOVA. Another one, normally distributed. Your data should be normal distributions. Homogeneity of the variance, the variations within the each group being compared is similar for every group, similar for every group. If the variants are different among the groups, the ANOVA probably isn't the right fit for the data. Yeah. See, this is a third one. Anyway, let's move on to the, see, this is the steps. Performing a one-way ANOVA in SPSS. Number one, where we have to go, see this one first. Okay, might be, wait, my dear student. I should open the SPSS. My laptop might take a few minutes. Okay, it's open now. It's open now. Now I can share. Let's first have our look here. First steps, this one. Go to analyze. Before this first step, we have to import the data as well. We have to import the data first. The second step, analyze, then here. You must have at least one DV and one IV, okay? And IV should have more than 3 categories, not 2. If IV has a 2 category, we can go for independent t-test. Understand? So this IV, the fertilizer is a IV, the yield is our DV. The third step, okay, here dependent, and the here factor is the fertilizer. Now, one more things, go to the here. Go to the post hoc season, this one, post hoc, and then Toki, choose, click on the Toki, because which will compare, which will give you the result. Okay, which level has how much effect on your DV. And the other one is go for the descriptive. Where you can go to the descriptive? Here, see here, in option. If you click on option, descriptive will become. Description mean and the standard deviations data will come. Then continue and the button is okay. This kind of result will come. Now I have to run also. Wait, I'm going to share on the content. See. So now you can see that SPSS, the tab, SPSS page, right? You can see. Now I'm going to import first. I have a data for your practice. Where in this section, the research work. No research work, sorry. This section, usual research method. Yeah, SPSS. See here, this one is our data. Just open. Sorry. I'm not looking for this data. We also can work on in this data. But the ANOVA data, see this one. ANOVA, only ANOVA. Okay, my dear student. So there are the different variables, but I'm going to, because we are going to use a one-way ANOVA, so we cannot take more than one variable. Okay, only one variable. Might be we can go for different variable, but we have to run separately. Now fertilizer, I'm going to use separate, or might be I'm going to delete this one. Clear. Now I have a two variables. Number one is import the data. Number two, analyze. Go to the compares mean, and here one-way ANOVA. Here is the one-way ANOVA. See, so this one should go here, right? And this one should be here, right? Am I right? Yeah, no, my DV is yield. DV dependent here, and this is the factor I or maybe IV. Then go here and continue. The other one is descriptive analysis as well. Okay, now okay, result will come. Now the second step is interpretation of the data. Interpretation of data. Here you can see the type of yield. No, this data I can explain through the slides as well. I have on the slides data. See here. Okay, now this result will come. First, descriptive stats. Here, type of the fertilizer 1, 2, and the 3. 1, 2, and the 3. Which level is more effective? See this one. Have a more influential. Number 3. Number 2 is the more influential than number 1. Number 1 is a less influential. Okay, this is a standard deviation. They are standard deviations. Simply. Later, I will also tell you the how to do the reporting. Here, ANOVA. If this is significant, it means the difference is exist. If it's mean the alternative hypothesis accepted. If this value should be more than 0.5. My dear student, must remember the significance value should be more than 0.5. Less than 0.5. This is less than 1. If the value is more than 0.5, it means we have to accept the alternative null hypothesis. So this is the significant. Okay, now we can see the level contribution one by one here. Level 1, 2, and the 3 levels. Okay, with the level 1 and with the level 2. Let's see. Here, 1 and level 2. 1 and level 2 relationship don't have impact, but 1 and 3 has a significant value, and 2 and the 3 also have a significant value. Only 1 and 2 is not impacting. We also can see from here. See here, we also can see the less impact. See here, the mean is very small, less impact. See, my dear student, this is the result. And the further one more information, one more example for you. I already calculated for this one here. Sample. Here is the null hypothesis satisfaction not differ among the countries. Okay, countries should be more than 2, sorry. The alternative hypothesis satisfaction differ among countries. Now this is the result. Okay, so significant. It means this is significant. We have to accept this one, H1. We have to accept H1. Satisfaction differs among countries, right? So because this is result of significant. Now we can see the one by one, how one category impacting another category. See here, number 1, compare the value is more than 0.5, less than 0.5. So decided H0 is rejected. So H1 is accepted. If this one is rejected, then we have to accept this one. Conclude, satisfaction differs significantly among countries. Satisfactions not equal. Different level have a different satisfaction in different countries. Okay, and then post hoc significant pairs are found between. And this one, how to report this result? Number 1, Singapore and China is significant, this impact. Singapore and India, this one. See here. Singapore and China, this one. Singapore and India, this one. Sorry. Here, Korea, here. And Korea and the China, this one, this significant. We have to see here. Hello. Walaikum. Okay, sorry, I had a call. See how to report this one. So further, how to report in the paragraph in APA system, APA style, sorry, not system. One way ANOVA between group analysis variance was performed to investigate the mean difference of satisfaction among countries. Or maybe in the first one, we also can see one way ANOVA between groups analysis of variance was performed to investigate the mean difference of fertilizer type fertilizer, or maybe the mean difference of yield per acre among types of fertilizer, right? Based on the table, the result shows a significant difference of customer satisfaction. Yeah, difference because we have a difference. The result indicate that the level of satisfaction is differ among the customer from Singapore, China, India, and the Korea. The finding is constant with the previous finding. Maybe you can support from the previous research that highlighted the role of country in the determined customer satisfaction. Based on post hoc multiple comparison analysis, significant difference are found between this one, China, and here. Also, here is also significant difference. Let's see in the result of here. But here we couldn't find the first example. See, type 1 and type 2, we couldn't find any difference here. No difference between type 1 and 2. But type 1 and type 3, we found a difference. And also type 2 and 3 also find a difference here, significant value. Because this significant is value less than 0.5. But this one is more than 0.5. It's mean no difference. It's been rejected. Alternative hypothesis is rejected. Null hypothesis is accepted in this case. Hope you got it. There is any question you may ask me. That's all for today's lecture.